In this video, we're going to look more deeper into the normal distribution. In the last video, we talked about the different properties of the normal curve, and we highlighted some of these properties, which is this one: the mean of the curve is equal to the median and is equal to the mode. But now we get to see what the normal distribution actually looks like as a graph, and let's look at its different properties as well. One standard deviation away from the mean or mu in either direction on the horizontal axis accounts for around 68% of the data. Two standard deviations away from the mean accounts for roughly 95% of the data, with three standard deviations representing about 99.7% of the data. So as you can see, the graph that you're seeing right now is the graph of a normal distribution. So it is symmetric because, as you can see, when we divide it into two by that line there, then we get to see that it's similar on the left side and on the right side. Also, although the tail seems like it touches the x-axis, they don't, and it goes infinitely without end. Further, this tip there, that tip there is actually the mean, at the same time the median, and at the same time the mode of our distribution. So that value is very powerful to represent our distribution. Further, as you can see, the measurements below on the horizontal axis, which the center of our mean, is defined by the standard deviation. So if you are one standard deviation away, like if you remember when we use standard deviation, especially in probability distribution, we tend to add and subtract the standard deviations so that we have some range, or we have a range of values rather. So if you have one standard deviation away from the mean, so that's a mu plus one standard deviation, and this is the mu minus one standard deviation, then we already have 68% or 68.2% of our data. This is one of the main reasons why the distribution is so-called normal distribution, because almost all of the values are in this area, are in the middle area, which are considered to be normal or average. While on the other hand, if you go two standard deviations away, roughly you already have 95% of the data from here to here. That's already 95% of the data. And if you go from here all the way to here, that's already 99% of the data. And clearly the data here are more or less outliers in our distribution. But since our measure of central tendency is both the mean, the median, and the mode, that mean, although it might represent the outliers, are not much affected because it is the median, which is pretty resilient to our outliers. The specific rule that was just mentioned is called the 68, 95, 99.7 rule, or the empirical rule. 68% of the data, 95% of the data, and 99.7% of the data. So as we can see in this illustration, since 68% or almost not almost, but actually majority of the values are in this red zone, which means majority of our values are in the average or in the normal. That's why the normal distribution is quite powerful, because if majority is not extremely on the positive side nor on the extremely negative side, then chances are we have a good representation of our data. Further, natural variables have the tendency to be like this, on the average. So if we will try to search for some variables that are occurring in nature, more often than not they would be on the average, hence they will be normally distributed. Let's have an example. Suppose SAT scores roughly follows a normal distribution in the US population of college-bound students, and the average math SAT is 500 with a standard deviation of 50. Then, 68% of the students will have a score between 450 and 550. 95% of the students will be between 400 and 600, and 99.7% would be between 350 and 650. So let us illustrate that using the normal curve drawing that we had a while ago. So let's say the average SAT math score is 50. Therefore, we can declare that our mean is 50. And if the mean is 50 and it's normally distributed, we can say that not 50 rather, but I think 500. Since 500 is our mean, that's also the middle score and that's the most occurring score. So most of the students will most probably have gotten a score of 500. Not only that, it's the middle score, and when you average all the scores, it's also 500. So 500 is our mean, the middle score there. Now, since we have a standard deviation of 50, that means if I will have plus 50 here, which is the standard deviation, I will have 550. A minus 50 here will get me 450. So that means because this is normally distributed and by the empirical rule, 68% rather of the students will have a score from 450 to 550. And we can already assume that simply because the distribution is normal. Further, if I will add another 50 here, that becomes 550 here, and this becomes 400 here because that's a minus 50. And because it's normally distributed, I can safely assume that 95% of the students have a score of 400 to 550. And the same goes. Another plus 50 here will give me a 600. Another minus 50 here will give me a 350. Hence, I can say that, it's covered. 99.7% of my data has a score of 350 to 600. Because of the empirical rule, we can safely assume these assumptions, and we can actually assume more because the data is normally distributed. And we'll look at that in the next video.